Hi everybody. So yesterday we finished off with standard atomic notation and talking a little bit how we got to things like atomic number, atomic mass, and number of neutrons. Today we're going to be using that to create the next thing in our journey, which is Bohr-Rutherford diagrams. So hopefully you remember a little bit about this from last year. You probably did these to death. This year we'll take a look at it briefly. And then afterwards we'll really be using Lewis dot structures more, but this is always a good lead-in. So if you remember from Bohr-Rutherford diagrams, the first shell can only hold a maximum of 2 electrons. And after that, we're pretty much set because the rest of them can hold 8. So the second shell can hold 8, third and fourth shell can hold 8, and if you have a fifth, sixth, seventh shell, those can also hold 8 and up, depending on what period you are in. The nucleus only contains 2 of our subatomic particles because remember the electrons are flying around the nucleus. So the nucleus only contains the protons and the neutrons in our Bohr-Rutherford diagrams. So when you're doing Bohr-Rutherford diagrams, very important that you put the number of protons and the number of neutrons in the Bohr-Rutherford diagram and list them in the nucleus. So let's do one together. So we're going to take a look at neon. The standard atomic notation is given there for you. Don't forget standard atomic notation at the very top there, that 20, that represents the atomic mass. The 10 represents the atomic number. And the atomic number is very, very useful to us because that instantly tells us the number of protons. So take a look at that number 10. That's the atomic number, so that means that my proton count would be 10, which is great. Like we talked about yesterday, everything on the periodic table is electrically neutral, which means that the number of protons always equals the number of electrons. So based on that, we get the number 10 as well. When it comes to number of neutrons, all you need to do is take your atomic mass and subtract it by your atomic number. What might be easier than that is if you have the standard atomic notation given to you, which is this thing up here, all you need to do is take the top number minus the bottom number, and that will always give you the number of neutrons. So 20 minus 10 will again give me 10. Now, we want to make the Bohr-Rutherford diagram happen, so let's get into it. Electrons in the first orbital, well, we have 10 total electrons that we want to plot, but our first orbital doesn't hold 10. It only holds 2, so that's all we're going to put in our first orbital. After that, we need to plot another 8 electrons, and luckily for us, the second orbital holds exactly 8. Which means that we've plotted 2 plus 8, which is all 10 of the electrons that we needed to plot. So in our third orbital, we actually won't need to plot anything at all, which means we're going to get 0 electrons in our third shell. So before we even start plotting electrons, very important we get that nucleus out of the way. So we're going to list the number of protons and number of neutrons that we have in our nucleus here. So let's take a look at that. Perfect. And afterwards, we can start plotting our electrons. So we said the first orbital gets 2. And remember, these things have the same charge. Electrons are always negative, so they want to stay as far apart from each other as possible. So in our first orbital, we always put one at the top and the next one at the bottom. Try to make them as far apart as they can. When it comes to our second orbital, we need to plot 8. So we kind of work like a clock. We start at the top and then we start moving right. So we put one here, the second one there, third one there, and the fourth one there. So now we've plotted 6, but we need to get all the way up to 10 in total and 8 in this last shell. So what do we need to do? Well, we just start doubling up. So that would be my 7th electron, my 8th electron, my 9th electron, and my 10th electron. And I think we have done it. So we have 10 electrons, 10 protons, 10 neutrons. That represents neon perfectly. We are good to go. So there's a couple examples there that you're going to need to work on in order to make sure that you got this concept down, but that'll be part of your homework tonight. Now, the biggest thing that we always take a look at is valence electrons. And remember, valence electrons are the number of electrons in that outermost shell. So whatever my last shell is, the electrons that are included in that shell would be considered valence. So the one we just did, neon, it had 8 valence electrons in its last shell, which means it has a full shell. That's called satisfying the octet rule. And oct, which would be like an octagon or an octopus, means 8. So octet means that we have a full shell of 8 electrons. And that's generally true for every element except for helium. Helium is in period 1, and it only has 2 valence electron shells, but we still consider it to be full. The big definition you need to know is this one here, valence electrons, the electrons in the outermost shell. So these are the Bohr-Rutherford diagrams. These are given to you in your notes. You'll also be replicating these today as part of your homework, so if you do have questions about how they should look, please refer to this section of your notes to make sure you're on the right track. Generally, we don't really draw Bohr-Rutherford diagrams because they're just like a massive pain in the butt, so we tend to use Lewis diagrams instead. Way quicker, and for bonding, which you'll be doing tomorrow, it's a lot more convenient to draw. So, with Bohr-Rutherford diagrams, what did we do? Well, we took a look at every single part of that atom. We looked at the subatomic particles involved in the nucleus, like my protons and neutrons, and we also drew the electrons that surround it. When it comes to Lewis dot diagrams, we take huge shortcuts. So we don't care about the number of protons. We don't care about the number of neutrons. In fact, we don't really care about the number of electrons. All we care about is the valence electrons that are involved in that atom. So for nitrogen, we don't even need to worry about these 2 ones inside. We just look at the last shell, and we draw it pretty much exactly as we see it there. So we're going to end up putting 2 dots up top, just because we have 2 electrons over here. 1 electron to the right, 1 electron to the bottom, and 1 electron to the left. And that'll pretty much do it, and that's what we have here. So that will be my Lewis dot structure there. And you follow the same pattern for every single element that we could possibly examine. So your homework for today, and I imagine that all of you should be able to get it done in class, I'm going to ask you to draw the Lewis dot structures. So you have a worksheet in your package that has all of the different elements from 1 to 20. I'd like you to draw the Lewis dot structures for each of those elements. That should be very, very quick. And you should notice some very strong patterns. And then when you're done that, I'd like you to draw the Bohr-Rutherford diagrams for the first 20 elements. And that'll be it. So hopefully you get that done in class and get ready for some bonding tomorrow. All right, see ya.